Hey, what's going on, y'all? It is Sean of Math Swap Tutoring, and I have another video here. This video is going to cover exponents. Exponents are an Algebra 1 topic. And just for the record, before I even go into this, just remember that if you subscribe at mathswaptutoring.com/subscribe, you can get the notes that I use, that I prepare before I make my videos. Some of these are made for the video, some of them are made for actual tutoring sessions and whatnot, and then I use them in videos too, or use them for my videos. So anyway, again, that is Math Swap tutoring.com/subscribe, and that way you can get access to my free that's it. So my free math tutoring notes. So I do encourage you to take your own, but this is also something where you can get a PDF copy yourself. All right, so let's get on into this. So exponents. All right, so my goal is to really help you to understand what in the world this stuff is talking about, and maybe to give you a little bit more understanding than you are used to having about exponents. All right, so here you go. So first of all, let's say you have a number, and I just say 3, and you write this number right here. This is an exponent. The technical definition of an exponent is a small number that's written to the upper right, at the upper right corner of some base number. The base in this case is 3. The exponent is 2. It's just that number written right there, and it indicates a power of the base number. So this whole, really the whole expression is kind of like the power. So that's why you often talk about powers and exponents together, because they're essentially talking about the same thing. But this whole expression, this base raised to this exponent 3, it would be referred to as 3 to the second power. So you can kind of use the word power and exponent interchangeably, but this whole thing is 3 to the second power. And so what that means is when you raise this to an exponent, that's saying this is the number of times that I'm going to use this number as a factor multiplied by itself. So in other words, 3 to the second power is 3 being used as a factor multiplied times itself 2 times, which is, so 3 to the second power, or 3 to the an exponent of 2, is 3 being used as a factor, being multiplied times itself 2 times. So 2, there's 1, and there's 2, okay? So 3 to the second power is 3 times 3, which is equal to 9, okay? Easy enough. So that means 3 to the third power is 3 used as a factor 3 times, being multiplied times itself. 3 times 3 is 9, times another 3 is 27, and so on and so forth. You can also talk about it like with a variable, which, as we know, is a letter that stands for a number that you don't know yet. So for example, if you had x times x, that is x squared. Oops, let me actually write a 2. X times x times x times x times x is x 5 times, because x is used as a factor 5 times, being multiplied 5 times. So that's x to the 5th power, okay? So pretty easy stuff, pretty easy, pretty straightforward whenever you understand that. All right, now that we've talked about just really the basics of how powers work, let's lay some rules down, okay? So let's clear this out. All right, so let's type this here. So let's say if you have, okay, let me just type it. So if n is a positive integer, so that means n is 1, 2, 3, 4, or something like that. If I can type etc. And I'm gonna leave some space so I can write that in. Let me just do it this way. Hold on a second, y'all. Because sometimes it's better to type some stuff. Sometimes it's better to just handwrite it. So let's write the rest of it. So if n is a positive integer, then x to the n power is x times x times x. And this is n times. So if n is some positive integer and x is being raised to the n exponent or n power, then x to the n is equal to x times x times x, so on and so forth, with x being listed n times multiplied times itself. Okay, so that's really just a restatement, a formal statement of what we just talked about. All right, now next thing is what's called the zero exponent, which is this: x to the 0 is equal to 1. So in other words, remember, a variable is a letter that stands for a number that you don't know yet. So basically, if you have any number raised to the 0 power, it is equal to 1. So you can have, I don't know, 5 to the 0, that's 1. 28 to the 0 is 1. 1/2 to the 0 is 1. 4,556 to the 0 power is equal to 1. It doesn't matter what it is. If it's a number raised to the 0 power, it is equal to 1. All right, let's keep on going. So this next thing is negative integer, integer exponents. So same thing. If n, I'm kind of thinking a little bit too quickly here, so that's why I'm not writing this stuff right. So if n is a positive integer, like we said before, that means that it's, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, some whole number that is greater than 0. And x is a non-zero, this is important, integer. So that means that x can be a positive integer, it can be a negative integer, but it cannot be 0. Then this is the case here. So if you have x to the negative n power with n being a positive integer, this is going to be equal to this right here. Okay. So basically, if you have x, as long as it's not 0, x being raised to the negative n power with n being positive is the same thing as 1 over x to the positive n. Okay. So for example, it's always good to illustrate this with real numbers. So 3 to the negative second power, or, well, yeah, I'm about to mess up the way I phrase that. So 3 to the negative 2 power is equal to, looking at this rule, 1 over 3 squared, or 3 to the second power, which is equal to 1 over 9. Okay. Okay, let's do another one. What about 5 to the negative 3? So that's the same thing as 1 over 5 cubed. 5 cubed is 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. So that's 1 over 125. Now, if x is 0, like say it was 0 to the negative 2 power, essentially you have 1 over 0 squared. You can never, ever have 0 in a denominator. You can't do that. That's a situation that's called undefined. So you can't do that. Okay. So that's why it has to be a non-zero integer. Now it can be a negative integer. So say for example, you wanted to do this. And don't let all the negatives fool you. So let or slip you up. So let's say I don't want that like that. So let's say that you had -3 to the -2 power. All that is the same thing as 1 over -3 squared. So all you've done is this stays the same because this whole thing is to the -2 power. So now you have 1 over that to the positive 2 power squared. And so that ends up being 1 over 9. The same thing. Why? Because you have -3 to the second power, which is -3 times -3. And if you remember from the way that negative numbers work when multiplied times each other, a negative times a negative gives you a positive. Be careful with your sign, y'all. Just take your time. Take your time. All right, let's keep on going. Keep on going. Let's see if I can erase this. All right, so the next thing, and I encourage you to take your time, take your own notes with this. I encourage you to watch it over and over again too, because again, your whole thing is you don't want to just, you're not just trying to hurry up and get a grade. You really want to master this stuff, because the more you do, the more it will help you with other math. All right, so this is called a unit fraction exponent. So if x is a real number, and real just means it's not imaginary. If it's imaginary, it would be like, for example, you could have 4i. It would be a number that's followed by I, which is essentially when you take like a even root of a negative number. We don't have that situation here, so you don't have to worry about that. But I do have a video that explains the differences more between real and imaginary numbers. All right, so if x is a real number and n is a positive integer, then x to the 1 over n power. Now, I know that looks weird. Okay, now you're doing fractions, powers and fractions in there. It's not that bad. X to the 1 over n power is the same thing as x, the nth root of x. Okay. And so specifically, n has to be positive here. Okay, this has to be a positive number. Now, if n is even, if n is a positive, how do I say this? Okay, if n, I'm kind of getting ahead of myself a little bit here. So anyway, so let's just keep it here. So if x is real and n is a positive integer, then basically x to the 1 over n power is the same thing as the nth root of x. Okay. So like say for example, you had 9 to the 1/2 power. Note x is real, and then the n is 2, which is a positive integer. So that is the same thing as the square root of 9, which just so happens to be a perfect square, 3. Okay. Just remember, a root is a number. This is the root of 9, which is a number that if you multiply it times itself n times, in this case, n is 2, then you get that first number. Excuse me, sorry, y'all. All right. Okay. So let's keep on going. Okay, rational exponent. So all this is if you have x being a real number, just like here before, and m and n are okay, so x is real, and then m and n are positive integers. Then x to the m over n is equal to x to the 1 over n all that raised to the m power. And it's also equal to x to the m, all that to the 1 over n power. So basically, all that's saying is that you can kind of split up the way that you define this whenever you have m over n like this here. It's just like all this raised to the m power, or all of this with the m raised to the 1 over n. So just take your time and really look at that. So let's do an example. So if you have 32 to the 3/5 power, for example. I know it looks weird, but just apply the rule. That is equal to 32 to the 1/5 power, all that to the 3rd power. Now, 32 to the 1/5 power is the 5th root of 32. So let's write that like that. So that's this here. And now I'm just applying this unit fraction exponent rule here. Now, there is a perfect nth root of there is a perfect 5th root of 32, and it's 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the 5th root of 32 is a 2. So that means now you have, so the 5th root of 32 is 2, and now you have 2 to the 3rd power, which is 8. 2 times 2 times 2 is 8. Okay. So you can kind of split it up that way, and it helps you to solve those type of problems. All right, not much left. I know it's a lot, but again, don't feel like you just have to like, oh man, I don't really understand. Just keep on watching it. Keep on watching it. Try not to feel too pressured, because you don't have to. Just take your time and look at the examples and whatnot. All right, the product rule for same base exponential, I'm gonna abbreviate that, expressions. All right, so basically all that is if you have these two. So say you have x to the m times x to the n. That's why we're saying product rule, because product means multiplication. If you have two numbers of the same base being multiplied times each other and they're both being raised to a power, this is the same thing as x to the m plus n. Okay. So say, for example, you had 2 squared times 2 to the first power, which is just 2 for the record. That would be the same as 2 to the 2 plus 1, which is 2 cubed, or 2 to the 3rd power, which just so happens to be 8. All right, let's do the quotient rule for same base exponential expression. So basically, if you have x to the m divided by x to the n, that is equal to x to the m minus n. Okay. So let's use the same number here. So in other words, you have two numbers of the same base and each is being raised to an exponent. One is being divided by the other one. Then you can subtract the exponents. So if you had 2 squared over 2 to the first power, that's the same thing as 2 to the 2 minus 1, which is 2 to the first power, which is just 2. Okay. Easy enough. Easy enough. All right. Okay. Power to a power. All that is if you have x, for example, to the m, and that's raised to the p power, then that is the same thing as x to the mp power. So basically, when you have something to a power and all of that is being raised to a power, then it's just all you do is multiply those powers together. Now, note that is different than the product rule. When you have two numbers of the same base being raised to a power, you add their exponents. When you have one number being raised to a power and all of that is being raised to a power, you multiply those exponents. So make sure that you look at it enough to understand the difference. Let's illustrate that. Say, for example, you had 2 squared squared. So we're saying that would be equal to 2 to the 2 times 2, which is equal to 2 to the 4th, which just so happens to be, what's that, 2 times 2 times 4? I mean, it's 4 times 2 is 8, so that's 16. All right, so, but let's look at this. So say, for example, we wanted to rewrite this and just prove. So what this ends up being is 2 squared is 2 times 2, and then you say that's being squared. So that's going to be 2 times 2 to the second power is this times the same thing. So that's 2 times 2 times 2 times 2. So that's 2 times 1, 2, 3, 4, 2, 4 times. Okay. All right. Now, what about power of a product? So you have xy to the p power. That is equal to, so in other words, if you have two different numbers that are both together being raised to the p power, that is the same as x to the p times y to the p. Okay. Again, take your time, make sure you understand what's going on here. So say, for example, you had 2 times 3, and that was raised to the second power. Just make it easy. That's saying this is 2 squared times 3 squared. Okay. Which happens to be 4 times 9, which is 36. Okay. So that's all that's saying. If you want to write it out and see, that's going to be 2 times 3. 2 times 3 squared is 2 times 3 times 2 times 3. So then you have 2 times 2. So that's 2 squared times 3 squared. See? All right, good. Now, the last thing I want to cover for this is called the rule for the power of a, if I can write a correctly, quotient. So if you have two numbers, different numbers, x and y, and they're being raised to a p power, then that is the same as x to the p over y to the p. Both of those being raised to the p power. So say, for example, you had 1/2. Let me do it a little different. We'll say 2/3. All of that raised to the third power. That's saying this is equal to 2 to the third power over 3 to the third power. You see what I'm saying? Really what it ends up being is 2 to the third power is 2 over 3 times 2 over 3 times 2 over 3. So you have numerator times numerator, denominator times denominator. So that's 2 times 2 times 2 over 3 times 3 times 3. So you have 2 to the 2 cubed and then 3 cubed, the 2 to the third over 3 to the third. Okay. All right. So there you go. It's pretty much that simple. Make sure you watch this as many times as you need to. I also encourage you to check out the rest of the Math Swap Tutoring YouTube page for various tutorials. I'm always adding tutorials. If you need tutoring, make sure that you go to calendly.com/math swap tutoring and schedule your free consultation. And I'll talk with you and set you up with me or one of our other tutors who will help you in whatever math subject you're dealing with a focus. Our focus is middle school, high school, and some college math courses as well. And we also do SAT math test prep. All right. Thank y'all for watching this. And don't forget to subscribe at mathswaptutoring.com/subscribe so you can get the notes as well. All right. Thank y'all and have a great day.